Welcome everybody, welcome to another lesson on the physics of the flat earth. Today's lesson is basically the geography, like the plan and the cross sections of the flat earth design and understanding its toroidal field and its expansion out from the center. Then we're going to go on to show you how we find the circumference of the flat earth without any of this Freemason BS of Aristophanes putting stakes in two different parts of the world. It doesn't work. You can't calculate anything in this realm from two different positions because everything is relative to the observer. Traveling from one part of the world to the other is not like adding 2 and 2 and coming up with 4. No, it doesn't work. It's all BS, and I'm going to link one of Simon Dan's videos to this to make a fool of him, because I am going to make a dick of him and the people that are like-minded. People who think they live on the outside of a globe, spinning ball. The globe is a model because they've taken the northern hemisphere, man's arc of horizon, and put it on top of a southern hemisphere, man's arc of horizon. Both relative to the observers, but they're both different because one is a northern hemisphere star rotation and one is a southern hemisphere star rotation. They are mirrored. So if they're mirrored, you put them both together like this, you've got yourself a globe, haven't you? But it's a model. It's not practical. We don't see one. You can't see the two together. Although we can film the night sky and star trail photography and see the two star rotations. So that's another thing. To understand the whole flat earth system, you need to get your head around the star rotations and what's actually happening. And I'll explain a lot of this. You see this, the northern hemisphere rotation, you see the southern hemisphere rotation, and there's a celestial tropical gap that divides the two skies. Just like it's divided the two hemispheres here on Earth. There's your center northern hemisphere. Compaction, divergence into the north, expanding out to the south. So south is expanding. Everything that moves south expands with the field. It's all relative to the observer. He's not to know. And he contracts back in again when he moves north. So the tropical gap here, just like the celestial tropical gap, it's the divider between the two hemispheres. And you should know by now that Earth is like a ring magnet. Physicists tell you Earth is like a magnet, but you should realize it's like a ring magnet. The hole in the middle is a very fine hole. Look, very fine. Nobody can get into this place in the Arctic North. It's called a place of inaccessibility. Nobody can get there because of the high pressure. You try to get out of here, south, very high pressure. We cannot because we exist in this flux. This is the flux of the Earth magnet. We cannot leave it. Electromagnetic field, we're of the light. We cannot leave the light. We cannot leave the magnetic field. So, I'll turn it into a magnet for you at the same time so you can understand how it works. This could be confusing too, actually. No, I won't, because if I draw a magnet like this, so that's the magnet, I have to draw the inertial plane at the center of the magnet, which means drawing a line through here as well. But in the Earth situation, the inertial plane is the plane of the Earth, sea level. So bear that in mind, okay? We're dealing with the Earth that's above this plane, because below the plane is negative, above the plane is positive. Or you could say it's a North Pole and a South Pole. So it all boils down to the same thing. But then like a magnet, we break it down again we can just continue to break things down again. So you can break it down this way, north and south, south or north. Then we break it down again this way. You could say, look, there's a jewel here because it's centre Arctic here. This is Arctic north. And so there has to be a south somewhere. Where's the south? They try and tell you that's out here. Well, there's the south, Arctic North Pole, you could say. But it's not out here. Arctic North Pole. What's this? It's another North Pole. The Antarctic is the north. It's north as well. They're both high pressure. The South Pole is back in the centre here. Okay? Just like they tell you on a magnet, they show you all the ion filings, all the flux. Very strong there, and they show it all down this end. Right? And what do they tell you in physics? Oh, very strong in the Arctic, very weak in the equator. So what's actually happening is this magnetic field is coming out of the poles, comes out of the poles, shooting this way. So they show all this flux here. The North Pole, they show all the flux here. But what they're not telling you is they are both North Poles and they are rushing to the South Pole, which is in here. The South Pole. And what did they tell you in physics? That very weak at the equator. So they're not going to see filings in here, are they? It's very weak, so they don't see it. So most scientists of today who teach your children a total rubbish have no idea that the South is here and here, both sides of the tropics. Is that not mind-blowing? When you've been taught for years that this is the north and this is the south, and that's where the field's going, it's total rubbish. When you take the globe, the field doesn't come out of the Antarctic and flow all the way around to the Arctic. It flows out to the tropics. Out to the tropics. So, I was about to draw the tropical boundary, which made me stop and think, well, I'll share this with you. This being equal, where like I'm about to divide this up, so there's a tropical gap. So this would be a northern hemisphere. This is the Arctic region, northern hemisphere. Then you'll have the. Really, it's a strong force and a weak force. Because every time we break it down, you've got a dual north and south. Okay? So we've got to understand that each of these has a south and a north. Because it's been split by the tropical gap. So do a proper M. South, south, north. They do not teach this at school. They're teaching you, your children, absolute garbage. Now, like I said, that's all equal. But in reality, it's not equal. I mean, you can look at this and then look at this. If I put a slice through here, and shot back through this way as a cross section, look how small the north is and look how big the south is. So this is when you get to understand a bit of ancient philosophy. 1 minute. And understand why rub a little bit of this off. Why? Well, we go back a bit. The e-glue, you've got the e-glue, or you can think of the turtle. That would be a proper drawing, or closer than this, way better than this, closer to reality. Okay, it's actually a phi ratio, of 1.618, and that's magnetism. Magnetism. South, north. This is your basically 3 to 2, say. Let's say if it was 3 to 2. You got 3 for the south and 2 for the north. It's not a 3 to 2 though, is it? It's not too far off. But anyway, phi ratio. And this is what it is. So when I'm going to draw the tropical gap here, and we know the tropical boundaries are 23.4 degrees, right? So I'll mark 23.4 degrees here like this. But it's not right, because this hemisphere here, if I'm going to draw it like this, is expanding. It's expanding. It just continues to expand right out south. Okay? So understand that. Understand this. Realise this. But this is how they do model it. It's easy to understand, but you've got to realise the difference here, the ratio difference. So I'll carry on drawing the design. So I'll see, it doesn't even work for the north, because you shrink. Everything shrinks back to the north. Shrink to the north, expand out to the south. Okay? So we ignore these 23.4 degree lines like this, and I'll just roughly put the tropical boundary in there, okay? Pretty well equal. It's quite wide actually. And there's your other one, right? When in reality, there's the tropical gap here. I could have left a bit of a gap there for the turtle's neck. Should we do that? So you get some better visuals. A lot of rattling going on here. Okay, so there's your northern hemisphere. Well, like I said, shouldn't be working on that either. So we go Arctic. And here is the other pole, which this is the center. This is the Antarctic. So realise up here in the center Arctic, we have Polaris. Out here in the center of this rotation is Polaris Australis. Notice it's not out here. The South Pole, what they call the South Pole, 66.6 degrees. They'll call that That's 90 degrees. We look at the dead center here, dead center. But the mirrored image is out here at the center. I can't explain that, it's not on my mind, but you think about it and you'll work it out. It's the mirror image, okay? Because whatever the expansion is out here, center of it is like the center of this, there's the center of that. But in the flat system, that is the center. Everything comes out from there. So this is the way it works. And all your star rotations are all centered around this. Okay? Now all these stars in the south are all the stars in the north. But they're mirrored. They're actually parabolically mirrored because of the shape of the toroidal field, the Earth's torus field. So if they come from in here in the centre Arctic, there's your rotation in here. There's the vortex, the centre Arctic vortex. All the stars in here are parabolically projected off the southern hemisphere here, back to the observer in the rotation. But that is one meridian, so everybody gets one slice of the pie. So it depends on where they are around here as to where the rotation of the north is at that time. And he's on a meridian line. So if he's out here, he's going to get this projection of this part of the sky here projected around him here. And he'll get that in star trail photography. The stars aren't doing 360 because they're actually coming all the way around from the east to move out of his horizon, that's his horizon, and move on out, continuing around here. So everybody's on one of these lines, so he's getting his rotation. This guy over here is getting his rotation centered around here. So if he's filming, say, in star trail photography, he fixes it dead south or dead north, that's his rotation. You start going more to the east or the west, you're skew whiffing the whole situation. It all gets, you're washing away from this nice rotation. But all the stars in here are mirrored from in here and more expanded, aren't they? I've just explained how it's all expanding. Okay? And it's the same as we get in a magnetic cycle. A magnetic cycle is like this, just like a sun and a lemma. There's your south, or there's your north, or anti-Arctic, anti, and there's your Arctic. Or northern hemisphere. But just use the word hemisphere. Okay? Hemispheres. That's how we call them. Well, that's what we should call them, hemispheres. So, have you got your head around that? Understanding all these rotations, many of them. That's his meridian, north to south. This is his. Let's say in South America. This guy's in New Zealand. This guy's in Australia. This guy's going to see South Africa. Now he's seeing, let's say, a portion centered off this rotation as it comes out of here, coming around from the east. But this guy, he's going to see his over here. He's not going to see those stars in the same position in his rotation because they haven't revolved that much when it comes to this guy. Because these stars are all drifting this way. So if that guy's star's there, so he sees it, say 4 p.m. or let's say 7. It'll be here at the same time at 7, but right now it's way around here. A few hours before, it hasn't got round to him yet, and even worse so here for this guy. But as this comes around like that, it comes around like that. And around like that for him, because it's all winding mirrored from in here as this turns. This is turning. It's turning this. But if you don't have a star, if you're not star trailing, you've got your shutter, you've got it on, you're following a star and start with a star tracker, you just see the full night sky and you're just going to track a star all the way out of your horizon. It's going to, just you track it anywhere in here, you're going to see it go out. It just goes out beyond this rotation of yours. It's just moving on through its motion. All holographic projections from in here. All cast back to the viewer off the parabolic, concave, you can call it a mirror of the outer southern hemisphere. And then when you go deep, you start to realise what's happening on this concave sky. That's why everybody inside here gets his own personal projection, because of this crystalline mirrored structure of the moisture atmosphere in our toroidal field. So then you have the turtle neck, which is the tropical gap. Turtle's head, turtle back. So if we turn this into a magnet, so that the Earth is a magnet, we're going to have, where am I going with that? Well, the field comes out of the Arctics and they shoot up. Well, let's stick with the Earth. Let's forget the magnet for now. The field comes out of the north and comes up to the Tropic of Capricorn. Comes out of the north and goes up to the Tropic of Cancer, where it drops straight down into the ground. Like I showed you before, the magnetic field is very weak, so you don't see a build-up of the iron filings when they show all these silly images of a magnet filings. They just show you this and this, and then going to meet somewhere in here, nothing else, because it's so weak. So you're not going to get the iron filings building up here. It just drops straight down to the ground. But weak here, but they know it's a stronger force in here. This whole northern hemisphere region is stronger, so it'll come down and go through the ground to get over to here to find its balance, because weak to strong. And this field here is coming down here. Even though it's weak now, it's still a stronger force in the centre north than it is in the south. So it's going to seek equilibrium and go this way to find its balance. That's what magnetism is doing, always seeking its balance. So in the northern hemisphere, there's a strong force and a weak force, but then you break it down, because it's separated now. We have a strong and a weak, strong and a weak. So it's always working the same way as you break it down every time. Okay? So understanding this, you need to understand magnetism to understand the flat earth. You have to understand this, everything they haven't taught you. Everybody's ignorant of the truth, that's why they think flat earth is a joke. That's a magnetic cycle. In the flat earth system, we have a magnetic cycle doing this. Oh, no, sorry. It's the small end, that end, big, this end. That's the Arctic. That's the southern hemisphere Arctic. The energy is coming out of here. But it's infinite. 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 All the way around. I can draw lots of these. Infinite. All the way around here. That's the 24-hour sun when it gets out there in December 21st. And in the north, it has the same too. Your little head's up this end. The bigger foot's down the other end. Okay? Because they're separated. But then on a whole, you've got to realise on a whole it's one big cycle. These are all the things you have to consider when you think of the cycles of time. The timekeeper, the sun, what's the sun doing in the ecliptic plane? Down and out is right out to here. The sun's out, up and in. It comes back into the north. So there's one big overall cycle for the sun's analemma. But you break it down for each hemisphere, and then you break it down again into man's individual arc of horizon. We all stand within an arc of horizon like this. Okay? So it's all connected. Man stands at the centre of the universe. Everything's going on from the centre of here. Or you go right back to the beginning, everything's from the centre here coming out. This is the centre of the universe. The centre northern Arctic. There's a vortex in here. Our actual pure plasma sun is in here, just on the horizon of the black hole, which is the black hole centre, which is the dead centre. This is the ecliptic plane up the top. The planets are on. It's a wave, comes out from the black hole. A wave, a sound wave. The sun gets all the juice. First cab off the rank. That's why it's illuminated. Then you got the planets on each of these waves. High points of the wave, and we get a particle, an image of that energy wave. Every one of us gets one. It's called a planet. But down below we're in the 3D created from this illumination of the sun are all the stars and the moon cycle, which is an S cycle. There's different cycles. One for the stars over the day, up and down in the S. One for the moon, up and down over the month. And the ecliptic plane, flexing of the ecliptic plane, is the tropical season of the sun going up and down, which is in and out of the tropical celestial gap here. They call the ecliptic plane. Now, you need to realise this gap here, the tropical gap, how I've drawn it like this, is different in you've got to understand the difference between what I've drawn and celestially. Because in the stars is where we see the truth. And this tropical gap is off centre. It's not here. So when you're filming the stars at night, you can't see the difference between the two hemispheres. I don't think. Because you aim your camera towards the celestial tropical gap. You just think it's the centre, in the middle. And we look at maps and pictures of the Earth and we think, everything's in the middle. The equator's in the middle. Okay, you think it's in the middle. But look, it's offset. It's not. It's here. And we can see this in the sky. And this is why science tells you they don't draw where Orion's belt is the dead centre. Where Orion's belt comes is the dead centre. That's it. That's the ecliptic plane. But they don't draw it there. They draw it back in here a little bit more. So you need to understand why they've got it wrong. They've got it in the wrong place. Okay? They have to bring it back to where Orion's belt is, because Orion's belt is in the dead centre. Because it represents the three stars of Polaris in here. We look at there and we just see one star, but it's a 3-star, what do they call it? 3-star something or other. It's actually 3 stars. And this is why we can't see Polaris Australis out here, because it's been expanded, separated, so there's 3 separate stars. Which one's Sigma Octantis? Which one's Polaris Australis? Well, you can't focus on it, you can't see it. More widely dispersed and probably a weaker field. Hard to see. because the south is a wheat field compared to the north. But they all love to come out and film the Milky Way in the south because of the expansion, elongation of the Milky Way. See more of it. And you're away from all the city lights, big city lights of the northern hemisphere. I better stop the video there before we move on to man's arc of horizon and the circumference of the flat earth, because this video is going to get too long. It'll take ages to download. Okay, so this is video 1. So be sure to catch 2 and possibly 3, okay? If you like this sort of thing, don't forget to subscribe or go to the Patreon to find more information. And put a likes up. Thanks for watching. See you soon.